So today we're going to expand our factoring discussion and go into what they call cancellation or canceling in our text. And again, it comes down to making sure we have equivalence and simplifying the things we can simplify. And I have two examples on the board. I'm starting over here. We can only cancel with factors. When we have 6 divided by 2, or the fraction 6 over 2, we know that that is equivalent to 3. Why? Because 6 is 2 times 3, and when we have factors, and only factors, we're allowed to cancel common factors on the top and bottom. My result over here is, do you guys agree 2 plus 4 is equivalent to 6? I can still put that over 2. This fraction and this fraction are equivalent. But now instead of having a product in the numerator like I do here, I now have a sum. And if I try to cancel, I end up with the wrong answer. You cannot cancel out of a sum. But even though we don't like to do it, I come down that 2 and 4 have 2 common. And we have to see that these two numerators are the same. 2 plus 4 is the same as 2 times the quantity, 1 plus 2. But now I've gone from a sum to a product. And these are 2 factors. The 2 is a factor, and the 1 plus 2 is a factor. I cancel the factors. 1 plus 2 is my answer. That's equivalent to 3. We can only cancel when we have factors. And if we have a sum, we have to make it into factors, so there's a product. And when we cancel, we don't do it with numbers because we know how to do that from division. We do it with algebraic expressions like the one here in red. 2x plus 4. And what makes me just cringe a little bit is when I see an answer of x plus 4. You can't cancel this. 2x plus 4 is a sum. So our first step is you must factor. So I look at this, 2x plus 4, and I write it as 2x plus 2 times 2. And I see 2 is common, and some of you probably see that right away. So I pull the 2 out. It leaves me x plus 2. I check right now to make sure that the red and the black at this stage are still equivalent. Make sure I haven't broken any algebra rules. And over here is factor man. Now that's power. We've taken a sum and we've made it into a product of factors. And once we have factors, we can cancel and simplify. So this red expression simplifies to x plus 2. Now I can check it. I can pick a value for x and evaluate it. And I don't want to pick 0 or 1. So this time I picked 5. 5 plus 2 is 7. Up here, 2 times 5 is 10. 10 plus 4 is 14. 14 divided by 2, 7. So I know I have factored and simplified this one correctly. Now, I went ahead and just put up 4 examples for us to do. And if you want to try these, you can. The big step right now is to notice which ones have factors already and which ones have sums. So if you look at the 4 on the board, before we do anything else, which ones have factors currently? The only one that has factors currently is quadrant 1. 4 times the quantity a minus 3. Quadrant 2, 3, and 4 all have sums in the numerators. So they can't be canceled immediately. But quadrant 1 can. And the answer to quadrant 1 is 3. A minus 3. Now if I go to quadrant 2, what's common in 4a and 12? Well, the 4 is. If I pull that out and I check for equivalency, you notice I'm a tricky math teacher. Quadrant 2 is the same as quadrant 1, a minus 3. Now they get a little trickier. 3x minus 9x squared is a sum, or a difference. I view it as 3x plus a negative 9x squared. And the bottom is 3x. So that is already one thing. The top has to become one thing of factors. So I see the 3 can come out, and I see that the x can come out. And if you don't see that, try to go through this step. And right there, what I just did is I rewrote in the primes. But if I pull out the 3x, I'm left with a 1 minus 3x all over 3x. And we have to realize this 3x and this 3x can cancel. This 3x cannot. That is part of the 1 minus 3x. It is in these parentheses, which make it one hunk of junk, one thing. The answer to this problem is 1 minus 3x. And again, I could have substituted in a value of like 2 and make sure these expressions come out the same. 1 minus 3 times 2 is 6. 1 minus that is negative 5. 6 minus 36, negative 30 over 6, negative 5. And again, I'm very quick at this. That's 30 years of math for you. You can check it just by making some notes on the side. Last problem. 14x squared minus 2x in the top. It's a difference or a sum. 14x squared plus negative 2x. I have, and the bottom is one term, 2xy, so that's factors. 2x and y are the three factors. I have to make the numerator into factors. And the common this time again is 2x. So I have 7x, again, minus 1. So important you get the 1 there, because 2x times negative 1 gives you negative 2x. If you forget it, you don't have equivalency. And the bottom has 2x and y. And this time, what's exactly the same? Well, the 2's match. This x and this x match, not that one. 7x minus 1 is one thing. I can cancel those. But my answer this time is 7x minus 1 over y. It remains a rational expression. There's nothing to cancel the y, so it simply stays on the bottom. Remember equivalency and factoring and checking that your steps are the same prior to canceling. Don't get in a hurry. These problems take a little bit of time.